Doing good? Fine and ready for our class. I really appreciate those who have attended your weekly test, and those who did not attend, you can attend the upcoming tests. About the weekly test, if you are having the test on Friday, please submit it before Saturday morning, okay? If you are doing so, I can correct it, I can enter the mark and give it to, and we have to submit it to sir. If you are attending by Monday, Tuesday, it is not possible to correct, and because the next week paper will be coming. So, when you consider test, make sure of this point, and I really appreciate all those who have attended the test. Now come to the class. Last class you are learning about matter, right? You know that interparticle space, interparticle force. The space between two atoms is called interparticle space. The force between two atoms or molecules is called interparticle force. And left with Brownian motion and diffusion. What is Brownian motion? When you consider liquids, the atoms or molecules are loosely packed than solids and tightly packed than gases. When you consider such liquids, these atoms will move randomly. When you change when you touch the container in which the water is kept, it moves, right? So, in liquids actually the atoms and molecules will move always, and it is here in this, it will go and dash this and it will bombard that. It will move somewhere else. It will move somewhere and it will hit this. It will move somewhere else. Sometimes it will move and touch this container and it will come back. So in liquids, the atoms or molecules are moving randomly here and there, and this motion is always going on. So this is nothing but called the Brownian motion. The movement of the atoms or molecules is called Brownian motion. When you consider this Brownian motion, when you consider a solid, it is very less solid because it is very tightly packed. There is no chance for this atoms or molecules to move and get dashed with that walls. It is very difficult. When you consider gases freely move in the entire container. When you open the container, it goes out also. So, motion occurs in gases also. This is nothing but Brownian motion. Then come to diffusion. What is diffusion? Consider you have a glass of water. You drop a drop of ink. What happens? Within a short time, this ink will get into this water and it will get diffused. It will join with the water. This is nothing but called diffusion. About the diffusion, when you consider the solid, diffusion is a very slow process. For example, lead and gold. When you press the lead with the gold, it takes years to have some diffusion. A small change to occur, it takes longer time, even years it takes. So in solids, the rate of diffusion is too small, but in liquids, when you pour a drop of ink, it is easily get diffused. For solids example, you take a paper, you write something with pencil, rub. Immediately when you rub, what happens? This will get rubbed. But if you allow this for some time, 1 week or 2 weeks, after that when you rub, you have some black color traces. Why this is happening means, if you leave it for some time, the pencil traces get diffused into the paper and it is giving some color. This is nothing but diffusion. About the gases, diffusion is very fast in gases because anything can diffuse into gas. Because gases have many spaces, it is happening very easily. Then next one is interconversion of states of matter. Consider the 3 states of matter: solids, liquids and gases. Solids, liquids and gases. Can you change the solids into liquids? Where can you change ice into water? Changing from solid state to liquid state is called nothing but melting. Consider an ice piece. When you keep it outside the freezer, it is melting into water. So changing from solid state to liquid state is nothing but called melting. Then can you change liquid to gas? And in melting you have another point. When you keep the ice outside, at once it is not starting to melt. At a particular temperature, the temperature gets increased, and a particular temperature this solid will melt. That particular temperature is called its melting point. And when you consider this liquid to gas, is it possible? Yeah. Liquid to gas is called evaporation. When you heat liquid, when it is attaining a particular temperature called its boiling point, it will start evaporating into a gas. Then gas to solid, whether it is possible. Gas to solid. Possible. What is the process? That name of the process when it changes from gas to solid? It's nothing but called deposition. When a gas changes to solid, it is called deposition. Next, when this you come in reverse, solid changes to gas, it is called sublimation. Sublimation example, sublimation of naphthalene, sublimation of ammonium, etc. When gas changes to liquid, it is called condensation. And liquid to solid, it is called freezing. This is interconversion of states of matter. When you consider a solid like ice, when you melt it, it will change into liquid. When you heat it, it will change into gas. It is nothing but evaporation. Then when the gas is changing into solid, it is called deposition. Then reverse. When solid changes into gas, for example naphthalene and ammonium chloride, it is called sublimation. When gas changes into liquid, it is called condensation. When gas changes into liquid, what is the example? Consider the clouds. They are in gaseous form. It is coming down as rain. This is nothing but gas changing into liquid. It is nothing but called condensation, and liquid changes to solid. In all this process, temperature plays a role. Can you see? Temperature has some role in this. For example, one or two I will say. You have this liquid. It is changing into gas. What we are doing? We are increasing the temperature in this process. When you increase the temperature in liquids, it is changing into gas. And here, solid is there, ice piece. It is changing into liquid. Here also, we are keeping it in the room temperature. So, we are increasing the temperature. But you see the reverse one. Liquid changes into solid. When you have water, to make it into an ice piece, what we are doing? We are keeping it in the freezer. When you keep it in the freezer, what is happening there? There the temperature is reduced. So here the temperature is reduced. Like this, all this process, temperature plays a role. This is all about interconversion of states of matter. Clear? You want more, or this is enough for today? I hope it's enough for today. We can see once again about this. Consider a liquid state. space between these two is called interparticle space, and the force that attracts these two atoms or molecules is called interparticular force of attraction. Then Brownian motion. When you consider the liquid, always these atoms and molecules are in motion. It is moving here and there. Sometimes when it is moving from here to here, it will have a dash with that. Then it will push that to some other side. It will go and dash with the walls of the container. So this movement of the atoms or molecule inside the container, that is especially in liquid state, it is nothing but called as Brownian motion. When you consider solid, the Brownian motion is not possible, right? Whereas these particles are very tightly packed, there is no movement of atoms or molecules. Then what else? Next one is diffusion. When you consider solid state, example I said gold plus lead. It takes years to get diffused a small percentage. Even to diffuse a small amount, it takes years. But when you consider liquids, have water. When you drop a drop of ink, easily it will spread to all the water molecules present in. So when you consider about this diffusion is possible, highly possible in liquids. With solids it is very less. Diffusion takes years to happen. Then one more is gases. In gases the diffusion is too fast, because when you have some air, if you diffuse some other gas inside that, you have some air in balloon. If you diffuse some other gas, it will easily spread to the entire area of that balloon. So diffusion means the mixing, joining. We have one particle, one substance that is liquid, solid or gas. When you introduce some other substances into that, the spreading capacity or the joining capacity, this is nothing but called diffusion. This is all about diffusion. Then the next one is interconversion of states of matter. What are the things we have learned? When a solid changes to liquid, it is called, in the book back also there is a picture study using this solid, liquid, gas. And the solid changes to liquid, it is called melting. When liquid changes to solid, it is called freezing. Freezing, another name is solidification. When liquid changes to gas, it is called evaporation or boiling. Then gas changes to liquid, it is called condensation. Then gas changes to solid, it is called deposition. Solid changes to gas, it is called sublimation. This all depends on the temperature. In some places increase of temperature happens, and in some places decrease of temperature happens. In the book it is given clearly: heating, cooling. Melting is a process of heating. Freezing is a process of cooling. Gas to liquid, it is a process of cooling. When the clouds are cooled, it is coming out as a rain. So, it is a process of cooling. Liquid to gas, it is a process of heating. Only when you heat the liquid, it is boiling and giving out the gases. It is coming as vapors. So, it is heating. So, it is heating, it is cooling, it is cooling, it is heating. Then, this gas to solid, it is also heating. Solid to gas, it is sublimation. When you have some ammonium chloride, when you apply heat, it will change into gaseous state. Then this gas to solid, deposition, it is cooling. So in your book it is clearly given what is cooling, what is heating, which process undergoes increase in temperature, all this with the examples. If you read your book, you can clearly get idea about this. Only is a small topic we have covered this week. For the weekly test, whether there is weekly test or about the portions, we can inform in the groups. Okay. learn this, read your book. That's important. Picture study, simple picture study exercise also are given. Just for fun you can solve that. You can solve that, you can send it to me, I'll correct that. So when you read, you can solve everything in the book bag. First listen, then read, then you can easily execute everything. Clear? So this is all about today's class. I hope you all understood about today's class and get ready for the next class. We can meet in the next class. Thank you students. Have a nice day.